Welcome to lecture 2.2. Our focus in this lecture would be on the performance of an algorithm. So before we get to that, let's take a look at some of the key things that we understand from programming. There are three key constructs in programming: sequencing, iteration, and decisions. And sequencing is the process of going through a set of instructions, in this case set x to 1, set y to 1, add 1 to x, and subtract 1 from y. And you can take that sequence and change it, change the order of the sequence, but it could cause an error condition. In other words, when you say add 1 to x, the value of an x is not defined. So x has nothing in it. And so the reason that we say set x to 1 before we say add 1 to x is to make sure that x is defined. Iteration is, as we saw, condition true, you're going to go into the loop body and continue that until the condition is false. So there are two types of iteration things, while and the for loops. Branching is decision making in here, that you look at a condition. If it's true, you go to the left, you do statement 1. If it's false, you go to the right and do statement 2, and then you continue to the next instruction. So a problem like this, given a nested if statements, we call this nested because one condition must be true before it checks the two conditions. So we can ask the question, when will the statement 1 be executed? For the statement 1 to be executed, the test condition 1 and test condition 2 must be true. Statement 2 to be executed, the test condition 1 must be true, otherwise we wouldn't come here. But test condition 2 must be false because you're in the else statement. For the statement 3 to be executed, the test condition 1 must be false, and then you go into the statement 3. I'm going to skip through this one and get to the idea of testing. Let's talk about why we test programs. We have to tell a computer what to do is a difficult task. We have to tell this computer. So we need to follow logical instructions in the correct order. We test programs to see if the program works as intended. So how do we test programs? Each program is different. Therefore, the test cases depending on what the program is trying to accomplish. So finding the correct test cases is also a difficult task that requires careful thinking and consideration to see what can go wrong with the code. So we'll consider a few examples next. Let's take a look at test cases for a vending machine. We talked about a vending machine where we put 25-cent coins and then we get a drink if you have 50 cents. So let's go back and think about this. So what are the possible test cases for vending machine program? We can say user inserting the wrong coins is a test case. We have to check for that. Users inserting no coins and requesting a drink is another error condition, and we have to check that. Users inserting insufficient coins and requesting a drink is another problem, and we have to check that. Users changing mind and pressing cancel after inserting coins is another problem that we must deal with. Users inserting the correct coins and requesting a drink is another thing that we have to test. When it comes to an ATM program, let's think about what conditions are required. How do we do test cases here? So suppose we write an ATM program, what are the possible things that can go wrong? So it's possible that the user's card is invalid or expired. So we have to send a message and void the transaction. It's possible that the user input is wrong in terms of the PIN number that the user entered. So in this case, we have to tell the user the PIN is wrong and enter the PIN again. It's possible after you go through all that, the amount entered is not a multiple of 20. Most banks like to give multiples of 20. So we may ask the user to enter a multiple of 20. And then you must check if the user does have enough funds to withdraw the amount that the user is asking to withdraw. If it doesn't, then you must inform the user to ask to enter a small amount. It's also possible that the ATM ran out of money, and then in that case, we will say sorry message and ask them to check back later or go to a branch. So those are possible cases for an ATM program. So in this case, we're asking the users to write a program in the workshop, find the semester GPA given the number of A's, B's, C's, D's, and F's. We assume that A is worth 4.0, B is worth 3.0, and so on. We want to clearly identify the assumptions, input, error conditions, and formula for computing GPA and the output. So these are the things that are required before we even begin to write the program. What assumptions do we make? We assume that A equals 4.0. What inputs do you want from the users? We want the number of A's, B's, C's, D's, and F's. What are the error conditions? The user may enter a negative number for the number of A's or B's. Then we have to inform the user to enter a positive number. How do we compute the GPA given the A's, B's, C's, D's, and F's? What output do you want the user to see? In this case, it says find the semester GPA. So the output is a number that denotes the semester GPA. So how do we solve this problem? Let's take a look. So first we read the number of A's, we read the number of B's, and then we read the number of C's, D's, and F's. And then we compute the sum as 4 times A. If the number of A's is 2, then sum is 4 times 2, that's 8 plus 3 times the number of B's, and so on. So you get a total sum, and then we compute the count of the grades, how many A's, how many B's, and so on, as A, B, C, D, F. And then we compute the GPA as sum over count. Then we display the GPA. Now, we note that we didn't include the error conditions. If we include the error condition, each statement must be checked. For example, if you read an A, is A greater than or equal to 0? You have to check that. So in this case, we have demoed this program without the error conditions, and you can think of how to add the error conditions into this code. Let's say we want to write a program for finding the highest mountain in the world. Our input is the heights of all mountains in the world, and our output is the highest mountain. We want to identify the input errors as a result of this program. So let's suppose we are trying to find the highest mountain in the world. So let's assume that the highest mountain in the world is height 0, which is an unreasonable assumption, but we need to have some initial number in the max height to get started. Then we say for all mountains in the world. In this case, we use a for loop because we know the total number of mountains in the world in advance. We don't need to use a while loop. We just use for all mountains in the world. Then we read the height of a mountain, and then we compare the height of the mountain to max height. So the reason that we set the max height to 0 because we need to have something to compare. If you don't have this statement, then this would throw an error message. And then if the height is greater than the max height, then we know the max height should be this new height. So we set the max height to height. Else we do nothing, and that's the end of the statement, and that's the end of the for loop. So going back to this, at the end of outside of this loop, what you need to do is to display the max height. And that's going to be the max height of this mountain. So here's another program that we will think about. How much a gym membership cost per year if the requirements are there's a fixed membership fee of $60 a year, special equipment cost of $2 per use, a 10% discount for military, senior citizens get 20% discount. Each month, user must pay at least 1/12 of the membership plus the usage fee. So the input we want to determine based on the requirements we have here. Our output is going to be the monthly charge per user. Our error identification would be based on the input errors that we will get. So we'll take a look at this code. So here's the code that will do the thing for us. We set the fixed fee to $60. We display, please enter your name. We read the name, while the name is not valid, so if the name doesn't look like something that's in the database, then we display the name is not valid, please try again, and then we read the name and go back to this loop. So this is sort of an error condition checking. You will stay in this loop until you enter the correct name. Then we ask the next question, display how many times you use the special equipment. So in this case, we read the usage and then we look at the usage. If usage is less than 0, we know it's an incorrect input. So we display a message and go back to it. So similarly, we ask for all the things, and then you can see that once I get all of those things, we compute the monthly charge as the fixed fee divided by 12 plus usage. Then we ask the question, are you a veteran? If it's a veteran, then we will give a 10% discount. You multiply by 0.9. If it's a senior, we give them a 20% discount. We multiply by 80. So we note that the error conditions are handled in those red coded blocks. So this is the end of that demonstration of how we look at the performance of an